Today we're going to talk about a factoring technique called the difference of squares. Alright, instead of just telling you how this works, I'm going to show you by having you do a little bit of multiplication. Alright, so we have 4 multiplication problems here. I'm going to go ahead and multiply the first one. If we multiply this using our distributive property, we'll end up with x squared minus 5x plus 5x minus 25. And you'll notice that this negative 5x and positive 5x, that adds up to be 0. So we end up with x squared minus 25. All right, I would like you to multiply 2, 3, and 4. Also, if you look at the directions here, it says not only to multiply, but figure out which product is not like the others. In other words, out of these 4 problems, there's going to be 3 that are similar and 1 that's a little bit different. Figure out which one is different. Please pause, multiply, and then figure out which one's different. Alright, let's see how your multiplication came out. For 2, this one should multiply to be this, x squared plus 6x minus 6x minus 36. And the 6x and negative 6x add up to be 0, so we end up with x squared minus 36. For 3, we end up, if you multiply this, you get 9x squared minus 21x plus 21x minus 49. And if you were to simplify that, you should end up with 9x squared minus 49. Number 4. This one is x squared plus 4x plus 4x plus 16, which simplifies as x squared plus 8x plus 16. So which one is different? Hopefully you figured out that number 4 is different. Right? This one doesn't fit the pattern. Okay? The pattern that I want you to see is that we always ended up with only 2 terms, x squared minus 25, x squared minus 36, 9x squared minus 49. Right? You should also, hopefully you also notice that we always ended up with a minus in the middle. And we also always end up with perfect squares, 25, 36, 49, x squared, 9x squared. Those are all perfect squares. Okay? And the reason why that happens is because the factors are almost identical, except for the sign in the middle here, right? It's x plus 5 times x minus 5, x minus 6 times x plus 6, and 3x plus 7 times 3x minus 7. All right, when that happens, you end up with 2 terms at the end. Both of them are perfect squares, and then you always have a minus in the middle. So why is this important for understanding factoring? Right? Well, we can take advantage of this pattern. Right? Here's what I mean. All right. In number 1, we multiplied x minus 5 times x plus 5, and we got an answer of x squared minus 25. Well, what does that mean about factoring? Well, that tells us that if I were to start with x squared minus 25, and I wanted to factor it, in other words, I wanted to turn it into a multiplication problem, well, x squared minus 25 would factor as this, x minus 5 times x plus 5. And if I had the problem x squared minus 36, right, referencing problem 2, if I were to factor that, that would be able to factor like this, x minus 6 times x plus 6. Right? If you don't believe me, you can try to multiply this out. X times x. Well, you don't really have to do that because we just did that up here. Right? So let's keep going. And looking at number 3, if I had given you the problem 9x squared minus 49 and asked you to factor that, that would be factored like this, 3x minus 7 times 3x plus 7. Right? So basically, factoring, we're just going backwards from the multiplication. Instead of multiplying it, we're taking the problem and turning it into multiplication. Right? And again, I want you to notice this pattern. Right? You start out here with 2 perfect squares, and you have a negative in the middle. And then we ended up with 2 factors that are almost the same, but one's positive, or this one's positive, this one's negative. Okay? And I could give you a new one that I haven't given you. Let me kind of scroll up. Right? Think about this. If I had given you x squared minus 9, How could we factor that? Well, that could be factored like this. X plus 3 times x minus 3. Right? Or if I had given you x squared minus, I don't know, 16, that could be factored like this. X minus 4 times x plus 4. Okay? All right, keep this pattern in your head. We're going to kind of look at some other ones. All right, I would like you to do some more multiplying, right? And again, think about which product is not like the others, right? There's going to be one that's different from all the other ones, right? Go ahead and pause and multiply these, please. All right, let's see what you got. The first one, you should have this, x to the 4th plus 3x squared minus 3x squared minus 9. That simplifies to be x to the 4th minus 9. The second one, you should have x to the 6th minus 8x cubed plus 8x cubed minus 64, which simplifies as x to the 6th minus 64. You should be seeing the same pattern, right? Ended up with two terms, perfect square, perfect square, perfect square, perfect square. All right, 7. This is the one that doesn't follow the pattern, right? You end up with x to the 4th minus 7x squared minus 7x squared plus 49. This is x to the 4th minus 14x squared plus 49. Right? So this is the one that doesn't follow the pattern. Okay, and the last one, I'm not going to go ahead and show all the work, but on this one you should end up with 16x to the 10th minus 25. All right? Let me real quick talk about the significance of this. Right? What's so important about this? Well, this tells us some stuff about if we wanted to factor these. Let's look at the first one. If I had given you x to the 4th minus 9 and asked you to turn that into a multiplication problem, or factor it, well, we just go backwards. This would end up being x squared minus 3 times x squared plus 3. Right? The middle one, or the second one. If I had given you x to the 6th minus 64 and asked you to factor that, well, that we would end up with x cubed minus 8 times x cubed plus 8. Right? Using the same pattern that we did from the first page. And then for 8, if I had given you 16x to the 10th minus 25 and had you factor that, you would end up with 4x to the 5th minus 5 times 4x to the 5th plus 5. Again, if you don't believe me, you can multiply these out. But we already did that, so you should figure that out. Okay? All right, so now, after doing all that work and understanding the pattern, I want you to do some factoring. Okay? So factor each one of these, except one of them. One of these is not going to follow the pattern. Okay? So go ahead and factor, and maybe I'll do the first one, right? X squared minus 9. How does this factor? Well, this follows that pattern that we've been seeing. We've got a perfect square, and a subtraction in the middle. So this one would factor like this. X minus 9 times x plus 9. That would be the factored version of x squared minus 81. If you don't believe me, multiply that out. Okay, go ahead and pause and finish 10, 11, 12. Figure out which one doesn't follow the pattern. All right, welcome back. 10, this one does follow the pattern. It comes out like this. 5x minus 6 times 5x plus 6. 11, this is the one that doesn't follow the pattern. Okay, so this one doesn't work. If you had put x minus 10 times x plus 2 maybe, you might think that works, but that doesn't. Because if you multiply that, you get x squared plus 2x minus 10x minus 20, which doesn't simplify to be x squared minus 20, right? So that doesn't work. Don't write that down. That doesn't work. Okay. All right, 12. This one follows the pattern. This one comes out to be x cubed minus 10 times x cubed plus 10. All right, one last thing I want to mention. Why doesn't 11 follow the pattern? The reason is because 20 is not a perfect square. All the other things we had were perfect squares. 25x squared, 36, 100, x to the 6, x squared, 81. Those are all perfect squares, but not this one. All right, let's have you practice some more. Factor each one of these, And again, one of them is not going to follow the pattern. Right? Please pause and do this on your own. Let's check your answers. 13, here's what you should have as an answer. This one factors as x to the fourth minus 12 times x to the fourth plus 12. 14 factors as this, 7x minus 10y times 7x plus 10y. 15 does not follow the pattern. This one doesn't work. Some of you might have put this down, x plus 3 times x plus 3. That doesn't follow the pattern. Right? Why? If I were to multiply that out, you get x squared plus 3x plus 3x plus 9, which does not simplify to x squared plus 9. So that one is the one that doesn't follow the pattern. 16, what'd you get for this? You should have gotten 3x squared minus 5y cubed times 3x squared plus 5y cubed. All right, lastly, let's take a look at these two. Right? You know, it kind of looks like these don't follow the pattern because I've got 2, 50, those aren't perfect squares. But you know what? There's something we could do. Right? We can actually factor out the greatest common factor here. So I could pull out a negative 2. And then I have x squared minus 25. Does that make sense? Negative 2 times x squared is negative 2x squared. Negative 2 times negative 25, that's positive 50. That works. Right? And actually, at this point, we can actually keep on going because this x squared minus 25 does follow our difference of squares pattern. So this factorization would be like this. Negative 2 times x minus 5 times x plus 5. All right, I'd like you to do this last one. See if you can factor this one. All right, let's see what you got. This one, first thing I would do is factor out the greatest common factor, which in this case is going to be 3x. If you factor out 3x, you're left with x squared minus 4. And then turns out this can be factored with the difference of squares pattern. So we have 3x times x minus 2 times x plus 2. And that would be the fully factored answer.